Good afternoon, everyone. My name is Nicole Carvalho, and I'm the Customer Care Manager here at GlobeNet. I'd like to welcome all of you today to our first webinar. We'll be covering SDN and virtual router. Today with me, I have our Senior Products Director, Gabriel Marcos.
Hi, how are you doing?
And Gabriel will be sharing some key insights and tips to better understand the potential of SDN and how virtual router might be the right decision for you. Our agenda today, we will start off with what do SDN and NFV mean. We will then lead into GlobeNet's virtual router service, and we'll finish off with use cases. I would like to remind the users that you are in listen-only mode, which means we cannot hear you. However, we do encourage questions that can be asked through the chat. We will be responding to questions throughout the entire presentation, so we do encourage and we welcome questions as we go along. So I'll now pass it on to Gabriel, and I hope you guys enjoy our first of many webinars.
Thank you very much, Nicole. One thing that we're trying to do here, reinforcing what Nicole just said, is that we want to be able to answer questions as we go along. So you don't need to, wait until the end of the presentation. You can ask any questions at any point, and Nicole, as a moderator, will read them, and I'll do my best to answer. Okay. So let's start off talking about two subjects that most of the time we get asked about. What's the difference? What's SDN? What's NFV? So and the reason why we want to start off with these two topics is because we're going to talk about a service called virtual router that has a little bit to do with each of these. Okay. So SDN, software-defined networking. When we talk about software-defined networking, this is a way of architecting the network. Software-defined networking has network-wide implications on how we separate what's called the control layer from the data plane. This basically means that the intelligence of the network is going to be in a different place. It's going to be separated from the data plane, or in layman terms, the decisions are going to be made separately from where the packets are forwarded. Typically, SDN, as I said before, typically SDN is related to NFV, although it's not necessary to have them both together. But the main point I want to make here is that while you will see most implementations of SDN also leveraging NFV, when we talk about SDN, we're talking about a type of architecture. Now, when we talk about NFV, network function virtualization, I see this more as a very tactical decision on how to deliver specific network services. And the definition of a network service is pretty broad. So you could be talking about services like routing, security, switching. I think that today we have a tendency to see more services more at the micro level, but the concept here, and what I leave you guys with, is that NFV is a very tactical decision. You may have heard, or you may have seen also the term VNF. There's a very subtle distinction between network function virtualization and VNF, virtual network function. But the main thing here is, while you may see VNFs and NFV in association with SDN, I would say 99.9% of the time, in the case of NFV, you don't really need SDN to implement it. And the example here is, if you have your traditional architecture based on specific purpose hardware, like you have a switch for switching, you have a router for routing, you have a firewall to perform security functions, through NFV, you can implement what's called a universal CPE, for example, and have the router, the switch, and the firewall all and other network services as well, of course, all running inside the same box, right? But as long as all decisions are made, especially all decisions about routing and switching are made within the box, then you don't really have SDN. Now, on the other hand, if you have a network-wide implementation of a protocol, like, for example, OpenFlow, and you have a very clear separation between where the packets are being switched and where the decisions for routing or switches and switching are being made, then you can say that you have SDN. So some of the advantages, and I'm also going to go through some of the terms commonly associated with SDN and NFV. Like, for example, you may have heard about orchestration or virtualization. As I was saying before, universal CPE, white box hardware, those are all terms commonly associated with network function virtualization. VNF, virtual network function, is also another term commonly associated with NFV. And here on the slide we have, you know, what are the reasons, or what are the advantages most commonly associated with each of these? And in the case of SDN, I believe, first of all, I believe there are common advantages to both SDN and NFV. It's very clear to me that whoever is implementing SDN and NFV is looking for both flexibility and scalability. These are common across the board, both for SDN and NFV. It's very clear to me that if you're doing any of this, you're looking for more flexibility, you're looking for more scalability in your architecture, in your network, in your services. However, I see, for example, a very clear advantage that's specific to SDN as centralization of management. So if you're looking to centralize the routing and switching and the architectural decisions of your network, that would lead you clearly to SDN. While if you are in a situation where you need to enable capabilities and new capabilities, new services on demand, then probably NFV is what you're looking for. And the reason for that is, as I was saying before, NFV allows you to make very tactical decisions about where to deploy specific services. You can even turn services on and off very easily, very quickly. You see it here on the slide in the report we're showing, you know, a bandwidth on demand, visibility, the ability to deploy value-added services on the fly. Those are all pretty much associated with NFV, but because it's a tactical decision, you can have those services enabled, you know, on a specific site, say, you know, in a data center or in a central branch, but not across the board. However, if you're looking to redesign your network and have this, you know, policies or these capabilities at a network-wide level, then you're probably looking at deploying SDN first and then enabling NFV. I think we have a question already. Nicole?
Yes, we do. We actually have two questions. So the first one, Gabriel, is what is SD-WAN?
Good. Thank you for starting with an easy one. So SD-WAN is most commonly associated with NFV, although I would argue that SD-WAN is also a form of SDN. SD-WAN actually stands for software-defined WAN. And in this sense, I see it very associated with SDN because it's a decision about an architecture. So in the case of SD-WAN, you may have heard, one of the most common use cases is replacing the legacy MPLS networks, especially for enterprise customers, replacing legacy MPLS networks with, internet connections. But also when you look at the, most, I would say to most of the vendors that are promoting SD-WAN solutions out there today, they are all making a very big focus on NFV as well. And the reason for that is that, there's a lot of advantages in combining both SDN and NFV, for a network-wide deployment. So you said we had two questions.
Yes, and the second one is, what is the difference with infrastructure as a service?
Okay, so that's going to be a little bit harder to answer, but let's just say that, let me answer that at two levels, right? So on one hand, if you look at what's most commonly understood or what's most commonly referred to, infrastructure as a service is generally referred to as virtual servers, virtual machines, and it's associated to things like, web servers or application servers. It's not really associated with these type of networking services. However, the reason why I'm answering this in two layers is because one of the things about NFVs is that it allows you to actually run these network services on virtual servers. So it's very, very common, especially in data centers, to see virtual firewalls, virtual routers running as software solutions in virtual machines or virtual servers, which is, of course, what infrastructure as service stands for. So it's all very, very related. Okay.
Perfect. I hope that cleared both of the questions up. If you have any doubts still, please feel free to ask. We're going to go ahead and proceed to the next slide. And again, we encourage the questions, so just keep them coming.
Great. All right. So now that we've talked about what SDN and NFV stand for, let's talk about a virtual router product. And what we're trying to do with virtual router, I would say, is a little bit of both. So at a very high level and at a very general level, what virtual router is a dedicated router that for all purposes, can behave and can offer exactly the same services that you would expect from a carrier-grade router. The only difference is it's running on a virtual infrastructure. So we have, within our SDN architecture, in many of our points of presence, we have enabled this capability to create dedicated routers on top of a virtual infrastructure, so that carriers and ISPs and companies in general can enable this network services without needing to have dedicated physical infrastructure deployed at specific points of presence. And of course, as we were saying before, you have the benefits of flexibility, scalability, and everything that comes with a software-defined architecture. Okay. So talking about architecture, the example here, when I first saw this, I thought it was, there were too many lines there. But actually, when you look at the typical architecture of an ISP or a carrier, or even a complex enterprise customer, you tend to see something like this. So you have multiple points of presence, you have interconnected branches, and you have the need to keep expanding the network to open, you know, a new branch or start providing services in a new location. And this is where virtual router comes in, because it basically allows you to extend the architecture and to extend the scope of the network in a very, very transparent fashion, without the need to deploy and, you know, dedicated hardware or dedicated network infrastructure. And you can literally use the virtual router as you would do with you know, a regular physical router. You can have, you know, one of them, you can have many of them. You can interconnect them and chain them in, you know, basically any way in which you would do with a physical router to actually get to the architecture model that that you need for your network. Alrighty, so in terms of the service infrastructure, as I was saying before, we have deployed virtual routers so far in 3 of our points of presence: in Miami, in the United States, and then in Brazil, in Fortaleza and Rio. There are new points of presence coming online very, very soon, so please stay tuned. We tend to announce all of these through our social network like LinkedIn. But the point I want to make is our infrastructure for virtual router is designed following the specs of the SDN architecture, so that we can create this virtual routers with any number of ports, with you know, different types of bandwidth, different types of services. We can connect, you know, different ports of these virtual routers to things like Ethernet or MPLS or IP transit. And again, as you would do with you know, a regular physical router, you can have several of these services connected to different ports on the same router. We can interconnect the virtual routers as well. We can define routing policies. So it gives a lot of flexibility, a lot of scalability in terms of ports, in terms of location, in terms of services, in terms of traffic, and we know, which is of course not subject to the limitations of physical infrastructure. Okay. And we're going to look at some of the use cases. So these actually come from our some of our customers, and these are things that we have learned. You know, why do people choose the virtual router service? Where, you know, where do they see benefits? So there's one that's pretty, I would say, pretty common with virtual infrastructure in general, not just virtual infrastructure for networks, which is associated to reducing risk. Okay, so whenever you're starting offering services in a new point of presence, if you have to you know, commit to a long-term infrastructure contract, you have to, you know, hire dedicated data center space, you have to buy hardware and port. I mean, you know, the entry barrier for that business goes up significantly, gets pretty high. And so the possibility of deploying new services and enabling new points of presence through a virtual infrastructure makes it very, very easy and lowers significantly the risk of doing that. The other very associated, I would say, factor to that is time to market, right? If you want to reduce time to market, you want to avoid all the, I would say, all the complications that typically come with deploying physical infrastructure. So in that case, a virtual router allows for a very, very quick time to market. The services are already available. So it becomes, you know, just a matter of deploying specific routing policies, designing the architecture, and that's pretty much it. There's also a very important issue about optimization of the resources. And I think I think this has to do with scalability. So when you're deciding the architecture for the network and you're committing to buy physical infrastructure, you have to make a decision, and whatever the decision you make, you're either going to have more resources that you need, or you're going to be running the risk of running out of resources pretty quickly. And virtual router avoids all of that, because you can define the virtual router to what you need today and then scale up or scale down basically as needed and when needed. So you could argue that has to do with risk, but I think there's a very specific point being made about even when you want to make the investment, even when you have the time to go to market, it also makes sense to try to optimize resources as much as possible. In terms of control, the virtual router gives you exactly the same level of control that a physical router would. So, you know, that's another reason to consider the virtual infrastructure. And in terms of updates, I think the point here is that virtual router is still a managed service. So while, you know, the customer has full control on the routing policies and they can manage the router, you know, as they please, it's GlobeNet that's taking care of the underlying infrastructure of the, you know, of the SDN, so to speak, of the physical infrastructure, of the connectivity. It's running on top of our backbone. So, you know, you just have to focus on managing the service, defining the routing policies, and making right to your business. And you know that GlobeNet is taking care of everything else. Okay.
And I'm back again. Thank you so much, Gabriel, for that. I feel like an SDN and a virtual router expert. And for those of you who haven't noticed yet, we do have a brochure that you can download. It's under handouts. I would recommend you go ahead and download that. It has many of the information that Gabriel shared with us today. And as Gabriel also mentioned, we do have new points of presence that will go online shortly. And if you stay tuned and follow us on our social media platforms such as LinkedIn, Twitter, Facebook, we will share that information once they do become available. So thank you very much for your time. Again, this is the first of many webinars that we will be having in the near future. So stay tuned. We will be announcing them as we get closer. But again, Gabriel, thank you very much for your time, and I hope everyone enjoyed our webinar. Have a wonderful day, everyone.